Hi, everyone. This is Rich Berliner from the In-Building Wireless Association, owned by Fifth Gen Media. I'm really happy to be here today with Payman Samadi. And Payman is the CEO of Eno. Eno is one of our sponsors at the event in Fort Lauderdale that we're doing on February 10th. And I'm really pleased to have him here with me today. Payman, thank you for being with us. And tell me a little bit about yourself and about Eno. First of all, I'd like to know about the name and how you got that name, and also about the company and the problem that you're solving for the industry right now.
Sure. Hi, Rick. Good morning. Thanks for having me. So, a little bit about myself. I have the background both in the academia and industry. I started more as a researcher in the photonics space. I was working on how to build networks using light for different types of applications, from supercomputers all the way down to long-haul networks. And then I kind of switched more on the software side and wireless side in the past 10 years and worked in a few companies and started and the name of our company came from our very first mission was about how we could make networks more energy intelligent. So it was energy intelligent network optimization.
Oh, good.
And that's how it started and kind of evolved to where we are now.
Gotcha. So, you are obviously, from your background, you're a tech head, and that's a very important thing at this point in time because you're doing something that's different from the standpoint of design software. And so, describe to us, if you can, what problem you're solving, what's different about what you're doing, and basically what, from your background, brought you into wanting to do this, because it sounds like this is a complete right turn.
Mhm. Yeah, so what we noticed was some shift in the importance of connectivity. It's kind of started during COVID that we realized things can be done remotely, from our work all the way to controlling devices. And then the past 2 years to 3 years, when AI era started, we started introducing a lot of new applications that basically require connectivity. It could be from very simple things in our homes that we have IoT devices, we have our streaming services, to commercial scenarios that we have post systems, we have security cameras, and it's now going all the way to industrial applications. We have AGVs, we have devices that are remote controlled, for example, in mining. We have excavation devices that people are controlling them from miles away. And very soon, we're going to see Industry 5.0, that is human robot interactions. We're going to have robots that are working with us, but they're also working together. And that means the importance of connectivity is way more than how it was compared to 10 years ago. And on the other side, when we look at the networking and connectivity itself, we also saw an evolution. If you were like 10 years ago, we had a Wi-Fi network for majority of enterprise applications, and we had basically cellular network for our public usage. Now we have a big mix of it. We have private cellular networks. We have neutral hosts there. We still have Wi-Fi and DAS there. We have fixed wireless network. Millimeter wave has come in. Halo networks has come in. So when we think about it, anything that connects to networks has significantly changed. The networks itself has changed, but the workflows that we have around how we build these networks and how we run these networks have barely changed in the past 10, 15 years. So we saw a big gap and we thought this is the right time to think about it in a different way.
So we agree totally on the connectivity and changes and the importance of all that. But I'm not understanding yet what Eno's product or service really is. So what do you physically do? Are you selling people devices to connect these things? Is it just design? What is the product offering or service offering?
Sure. So we are trying to automate the entire workflow, and the workflow starts by first there's a concept of the network that we want to basically say, I need a network and how it's going to look like. Our feasibility study, once it goes to the design, how it needs to be designed, and then once you go and build that network, how to validate it, and then from validation, you need to monitor that network and do asset management there. But I'd like to go a little bit back before expanding on, why what we do matters, on the urgency and why this problem is kind of very real. I gathered some stats that I think would be very useful for the audience there. That's how the way we use the applications are kind of changing in the AI era. There are two stats that I really enjoyed seeing. In one was that everything was kind of in the cloud, but about 40% of the application was coming back to the edge. And then there need to be some sort of local processing that happens there. Second, we're going to have agents that are specific for each type of workflow and tasks that we have. And then many of those agents in 2026 are going to be used there. And if you think about it, inside the US, even we just look at the enterprise world and industrial world, we have about, I looked, 600,000 manufacturing facilities. We have about 5,000 public airports. We have about 1 million warehouses and storage places. We have hundreds of ports. We have over 200,000 large commercial real estate. And if we do the same way that we are doing it now in terms of how to upgrade these networks and how to basically manage and monitor these networks, basically it's going to take forever to be able to go through that cycle. And this is not something quite sustainable. When we were talking to people, we realized a few things. First, we realized that from the time that an enterprise realizes there is a need for a new type of connectivity, it takes a very long time, months, 6 months to 1 year to be able to do. And this really matters because if I can use a new automated system for my supply chain, and that could sell me hundreds of thousands of dollars, that means I'm going to get that 12 months from now rather than getting it today. So it's a cascaded effect to enable how to run things in a more efficient way.
Right, so let me see if I understand. You're not sort of an RF design house. You are a network design house. So you're looking at designing all of the aspects, including the APIs and all those the other pieces that go into it, to design the network as a whole. Is that sort of a good thumbnail for the dumb guy on this call?
No, it's kind of like that. We are basically, RF design is a part of this whole system that you're looking at. Definitely, it's important to make sure that there is an RF signal there. But that's basically one of the building blocks to the entire system that we talk about there. And that's kind of how we look at it as an entire workflow rather than providing tools. Speaking of tools, now that we have different types of networks there, when there's a problem and you want to find the root cause, many companies need to use 4 or 5 different tools to be able to figure that out. That's not a really efficient system there. The second part of it is that when you have multiple types of network, you're in a scenario, for example, in a higher ed, you have a DAS network, you have a private cellular network, you have a Wi-Fi network. Now you have 3 different teams and each have 5 different tools. And if you do the math, it's a lot of inefficiency that happens there. That's why we kind of look at it as a different way and see how we could kind of combine this as one platform that you'd be able to do it agnostic to the type of technology that you're using, agnostic to the type of use case that you're using it, and agnostic to the type of vendor that you're using, right, and able to put that all together.
So I hesitate to go there with this terminology, but 6G has been represented to me as everything to everything. And it sounds like what you're doing is you're sort of lubricant on the everything to everything move so that there's efficiency in how the data moves from place to place, from system to system. Is that a good, accurate picture of what we're talking about?
Yes. The concept that's basically you're talking about, we're trying to introduce this concept of intelligent connectivity. And this intelligent connectivity has some attributes. The first one is exactly what you talk about, a unified workflow across the entire life cycle. So before the deployment, when we want to go as a system integrator, as an enterprise to understand how we need to build these networks, while we go and deploy these networks and do validation after our deployment there. And then day 2, once these networks are up and running, so we need to monitor it, but we need to also expand it because there's new applications that are coming in. Be able to put that all in one place for all types of technology, all types of vendors that we have, versus being able to, move around different tools, move around different teams. And there's actually a very interesting analogy there in the software engineering side. Before we had backend engineer, we had front-end engineers, we had basically DevOps engineer, we had AI engineers. Now with the new agentic models, you could see that everyone's a full stack engineer. Everyone could do everything there. We need to kind of introduce the same type of concept in connectivity world that we have these types of full stack connectivity engineers that they could do everything in one place and deliver that to the enterprise or the edge.
Interesting. So, one of the things that strikes me as you're talking is you're going to love the talk that Joe Bacuzzi, Dr. Bacuzzi, is going to talk about at our event in Fort Lauderdale. He's with NVIDIA. He's the principal 5G scientist at NVIDIA, and he's going to be talking about some of these topics. And it sounds like there's a real parallel between what he's going to be discussing and what you folks do. And by the way, I thank you so much for being a sponsor of this event next Tuesday in Fort Lauderdale on February 10th at the Downtown Event Center. But Dr. Bacuzzi was talking, and just in our preliminary discussion, about the edge and latency and what NVIDIA is doing and the NVIDIA stack and everything to everything. So I don't want to preempt his speech, but boy, there's a lot there that you're working on too. So I think that's going to be really interesting for you to hear what he has to say. So tell me about what kinds of companies physically will use Eno to do whatever they've got to do with their networks. What's the typical customer look like for you at Eno?
Yeah. So the way we have built our platform is to be agnostic to the use case. But certainly there are some use cases that connectivity is more important and they're more mission critical. There are several examples that can come up with it. We have customers that are in oil and gas and refineries. Those are the places that's quite important to have uninterrupted and reliable connection there. We have customers at ports when you want to unload and load and move around in the logistics that you have there. We have customers that are in manufacturing facilities that are doing a lot of AGVs and moving around things with these self-driving lift trucks there. We have customers at the airports that now we're introducing many new types of technology. One thing that we kind of start looking at a different way is that, and it kind of resonates with the conversations at NVIDIA, that at the end of the day, the network is serving a physical space. It is very important to have a correct and accurate information about that physical space. And what we saw was that, when we look at the workflow and the design, there's some interest in the physical space. There's some, tools that they have a 2D model or a 3D model there. It's very hard to build it. It takes a very long time there. Once you go to the monitoring of the network and management, usually there's a big disconnect between the physical space and what's happening there. So we believe this concept of 3D digital twin should be the core of the system, that you have it there, you update it as the things changes, and then from the day one that you go and build this network, or design this network, build this network, all the way to monitor it and then be able to expand it, because as you could see, the pace of new applications and automation is going to be much faster compared to even 3 years ago. So there's going to be new technology coming in, and they all require connectivity. Having an accurate system there is quite important. And we find solutions because building those 3D models are quite expensive, and it's not something that you could do from the get-go. So we have find ways to, in a very affordable way, be able to build those systems. And as we move through the workflow, and now we need some sort of more accurate ones, there are ways to, okay, now it's the time to spend a little bit more money, make it more accurate, do some imagery there, and take it from there.
Well, you've used a lot of terminology that floats in and out of my world all the time. Digital twins, self-driving cars, robotics, AI, agentic AI. So these are all really interesting topics. It seems to me, though, this is such an important product in a world where you're driving along in a self-driving vehicle that's using the terrestrial network, and all of a sudden that terrestrial network goes down. And so you need to then switch to the satellite network to be able to keep driving. But that's something that's not going to happen unless there's real planning that goes into making sure that that sort of quote unquote roaming happens, if you will. But it sounds like that's kind of your bailiwick. Is that accurate?
So we are more on the software side to provide enabling the intelligence side of it. We're not a company that provides the equipment or hardware or even the routings that happens there. We are a layer that kind of sits on top to be able to intelligently understand how my network is performing, how different types of networks that we have are performing, and what is the best way to monitor them, optimize it as we go on. And relating to that question that you talk about, having a good automated observability is quite important. So one of the aspects of intelligent connectivity we talk about is about autonomous execution. You have humans in the loop, but things are autonomous as possible. So if you think about it, you have those 3D digital twin models, and then you have an army of agents around it. And each of those agents is kind of one of the skills that we have as a sales engineer, as a design engineer, as a network engineer, as a validation engineer. And those agents are working 24/7, so we don't have to do it. And we are basically more of a general that are sitting there. We see our army of agents are working, and we make sure that we have the correct information. I'll talk a little bit about the monitoring side. At the moment, majority of the monitoring solutions that we have are not fully agentic in a sense that if there is a problem that is happening there, the user needs to go and basically done a root cause analysis. But now with agents, many of those could be automated. We could have systems that are monitoring the networks, different types of KPIs, tests across our Wi-Fi, cellular, DAS networks that we have. And once they find any sort of trigger points, they'd be able to have their own types of playbooks that they could run it and understand that, okay, what is the root cause of this problem? And gather evidence, provide a package of evidence, and be able to present it to the network engineer so they could make a decision and correct decision fast. And soon, even they kind of provide the action and we could trigger that action that are basically coming in.
Well, interesting topic. So, there's been a lot of buzz about Eno. That a couple of the folks that work with me have said they've been asked about Eno in a number of situations, and so this is a really interesting topic. I know that we'll get into it when we do the panel in Fort Lauderdale next week, and it just struck me what you're talking about. Interestingly enough, agentic AI, I guess the root of agentic is agent. So that the opportunity or the need to make sure that your network can handle an agentic AI so that there are agents to go out and do the work is very important. So this is really an interesting topic to me. And again, everybody who knows me knows I'm not a tech guy, but I'm really fascinated by what you're doing and how this layer sits on top of my networks and digital twins and all those things. But Payman, thank you so much for being with me today. We're going to get more into this in Fort Lauderdale. We're going to get warm. We're going to get into this topic, and we're going to be together. And you'll have a table and a spot at this event so people who want to come talk to you about this, and I hope plenty of our attendees will. But I've been talking with Payman Samadi today. And Payman, thank you so much again for being with me. We'll see you in a few days in Fort Lauderdale. Everybody out there, thank you for watching this. And this is Rich Berliner from the In-Building Wireless Association saying, see you in the warm weather. Bye now.
Thanks for having me. Bye.